So we're just going to let this go.
Hey everyone, I'm Abby from Science Around Cincy. We've all experienced the craziness of Cincinnati's weather. It can be sunny and nice out one moment and then thunderstorming or even snowing the next. Predicting the weather in this city is one of the toughest jobs around. So how is it done? I'm here at the National Weather Service Station in Wilmington, Ohio to find out how scientists keep track of our atmosphere. Hey Christine.
Hi, good morning.
Hi, good morning. Thank you so much for inviting me to the weather station.
Glad to have you here.
Cool. So what kind of observations do you guys get here?
So every day, twice a day, we launch a weather balloon and we send an instrument up into the atmosphere that collects all sorts of information for us. Primarily, it'll collect data about moisture, temperature, and then it'll have a GPS unit on it. And so as it moves up into the atmosphere and the winds carry it, we can get information about wind speed and wind direction as well.
Okay. So everything that you learn from the data from the weather balloon, how do you figure out what the weather is going to be like for the day based on that information?
So that information actually has a really great purpose. It will eventually get ingested into weather models, and those weather models can plot out into the future. And so as those weather models run different, we call them time step iterations. It's kind of a big word there, but as they run different iterations, we can get a look into the future, and it gives us an idea of how the weather is going to behave over our area.
Well, Christine, do you care if we head on out and take a look at the weather balloon that you guys are launching off today?
Not at all. I think that would be an awesome experience.
Okay, so we're out here in the National Weather Service Station field. You guys do all kinds of measurements out here to predict the weather. What are some of the ones that you guys are going to do?
Yeah, so of course we have a weather station that is on site, and we use that to measure lots of different variables such as temperature. We have our rain gauge as well, our anemometer, which measures wind speeds. But today we're also going to be launching a weather balloon.
Nice.
And a lot of those same variables that we're measuring at the surface, we're going to be measuring through the entire depth of the atmosphere.
That's crazy.
And so the reason we're doing that, we're measuring variables such as temperature and humidity levels, is because we want to have a sort of like 3D understanding of what's going on, because what happens at the surface may not be what's happening several thousand feet up in the atmosphere.
Okay. So how often do you guys launch the weather balloon?
So we routinely launch these balloons twice a day, once in the morning and once at night. And we base that off of Zulu time, so we always launch at 12Z and 0Z.
Okay.
And that is done across the United States, so everybody is launching routinely at those times. Now occasionally we may launch a special balloon at a different time of the day for an approaching hurricane. Could be one example that may be impactful to the East Coast. Or if we're expecting severe weather. That might be another situation where, hey, we've got severe weather expected at 4 o'clock in the afternoon. At 1 o'clock in the afternoon or 2 o'clock, we want to sample the atmosphere because we want to know, okay, weather models are predicting this. How is the atmosphere actually behaving? And so we send up a special weather balloon to get a better sample of the atmosphere.
That's cool. So pretty much you guys have a routine where you send it off, but if there's any kind of special weather event happening, you're going to go ahead and send one off just to get some extra data.
Absolutely, yeah, because that can help us understand, are the models predicting stuff very well? And also it just gives us a representation of the real atmosphere and what's actually occurring.
That's awesome. Well, I see you have the weather balloon set up right here. Should we go ahead and launch this bad boy off, see what we can find out about the weather today?
Yeah, let's go ahead and let's
All
launch.
right, let's go.
It's fun doing this in 20, 30 mile an hour wind as the balloon is bouncing around or even more. So we're just gonna let this go.
Oh.
Oh. That goes fast.
Oh. Bye.
Normally I don't catch it on my arm, but those things stand up to a lot of punishment. they're quite forgiving. So now the satellite systems have already detected that this thing is up in the air.
So this graph is developing from the balloon we
Yes,
literally just sent off a
yes.
couple minutes ago.
That's
so this
correct.
is developing like live.
Yes.
Right.
So as the balloon goes up, you are crossing and getting colder. But then once you hit the troposphere, you'll see that the temperature warms or stays steady through that layer of the atmosphere. The cirrus clouds we're looking at would probably be up around 500 millibars. And what that'll give us the temperature, and from the satellites we'll find out what the wind direction and the speed are from that.
So now that we've collected our data, let's check in with Chris and Allison back at WLWT to see what happens next.
So Allison, how do you use the National Weather Service data to make a forecast?
Okay, so the National Weather Service will put together their own forecast, and then sometimes their data also, their current observations, right, that's collected by these giant weather balloons, that data is then used to put into different computer models to put together a different forecast, right?
Okay.
So a lot of what we're talking about is models and forecasts and things like that. So we then go to these different computer models and we're looking at the output that each model is putting out for our weather scenario for the next, depending on the time frame, 1 to 2 weeks, depending. So what you're looking at here is we're looking at upper level winds because the atmosphere has several layers to it.
Okay.
So you start high and you work your way down to the surface.
So this is how far are we talking
300 millibars here. So that's generally, I would say, 300 millibars, about how high planes fly.
Okay, so you're
Generally?
telling 30,000 feet.
30 to 40,000
So
feet.
pretty far up there. Okay.
Yes. So we're looking at wind speed right now and
Okay.
wind direction as well. So this is an upper level low that's moving through the country right now.
Okay.
And we'll kind of go through the next couple of hours and watch as this moves across the country. But let's check it out closer to the surface.
Oh.
Okay.
It
changes.
It like disappeared.
Yeah, exactly, because we're looking at a different part of the
So
atmosphere.
we're farther down.
Weather is fluid.
Weather. Yeah, it's a fluid. It
Yes,
flows, right?
Yes, exactly.
Okay.
So it's changing and always changing. That's another consistent thing about weather is that it's not consistent at all. Okay, so now we're looking at, okay, we've got different wind speed, and then we've also got a little bit of a different wind direction as well. So whenever you have a difference in wind speed and wind direction, that's something called shear, and that's one thing we look for when it comes to severe weather. We have all these different ingredients that we want to look for severe weather. Shear is one of them, so the direction that the wind is either going or...
So it's like so the air's going in different directions. Is that
it
what
can be throughout the atmosphere.
Okay.
The direction of the wind might be coming in from different directions.
Okay, and you call that shear.
Yes.
Okay.
And there's also speed shear, where the wind is moving at different speeds too.
Okay, so in this case, we're looking at wind moving in different directions and at different speeds.
Mm-hmm.
Wow. Okay, so that could be a potentially severe storm.
Maybe. So then that's what we have to see. Is it lining up with also, is there enough lift in the atmosphere? So is there enough energy to lift this storm up and to create the giant storm itself?
Yeah.
Right? And then we're also looking for, hey, do we have a lot of moisture in the atmosphere too? All these different ingredients. And I think that's one interesting thing that people might not realize is that it takes everything to fall in line perfectly to see something happen with the weather.
Well, what are some of the challenges that you may have in forecasting some of these severe weather events?
Living in Cincinnati. Yeah, the location of Cincinnati, right? We're kind of a meeting ground for where the jet stream is falling and kind of sinking down to, and vice versa. So Cincinnati is in a very unique location where sometimes the storms are falling apart right as they're moving into Cincinnati. Sometimes they're only just now picking up steam right as they move past Cincinnati and things like that. So it can be a challenge, just specifically because of where we're located in the country. Another thing that's tough is the fact that, it is always changing, so you have to stay on your toes and be willing to roll with whatever is kind of thrown your way.
So it sounds like weather's always changing to begin with. So, but even in our part of the country, where we're at. Just it changes a lot because we can get it from pretty much any direction.
Yes, exactly. We do. We can get rain moving in from the east, which is super rare, but that happens a lot whenever we have the remnants of a hurricane moving through.
Yeah.
Yeah.
Yeah. Well, we pretty much get it all here in Cincinnati.
We do, which makes it fun.
That is fun. Well, Elsa, thank you so much for teaching me about our atmosphere and
Yeah.
why we see the weather that we see.
Always.
Yeah. And we'll see you next time on Science Around Cincy. Do you love science? Of course you do. So stay up to date on all things science around Cincy by subscribing to our channel and follow us on Instagram and Twitter @SciAroundCincy.